and today we will be sharing our assignment 5, sorry. So I have already downloaded this zip file that has a package of assignment 04, and in that we can see all the Java files. So let's open here. So we are presenting our complete ATM simulation for this assignment, which required us to implement a robust error checking and the cache dispensing logic. So the core architecture of this project is based on the state design pattern, which is perfectly suited for a machine like an ATM. So the state pattern allows an object, in our case, like the ATM's current state is like init, deposit, or withdrawing. So to change its behavior between the internal state changes, every operation such as hitting a button or entering an amount is handled by the current state, which then decides the next valid transaction. So I made the changes in the code display panel.java. So my focus was on updating the user interface that has been managed by this Java file. So to meet the assignment requirement, we needed a message for the withdrawal checks. So I created a new error message. This one that shows 20 only message one. So for the $20 bill only rule, for non-multiples of $20 and this one, sorry. So this one is for the $20 bill only rule. Then there is another one for show 20 request error for non-multiples of $20, and there is show requested limit exceed, that is for the cache limit check. Then for the cache limit display, the new show withdrawal limit, that is end limit method, ensures that the ATM announces the current cache that will be required by the withdrawal limit. And then there is critical logic fixing. This is the most important. We ensured that every time the display update, it logs the current state of the display button and the program variable to a text file. So in this line, so specifically in this line, we can see that it generates the required output for the testing. Now, state.java will be explained by Rupali.
Mm, Hi, I'm Rupali Vase. I work on state design pattern logic, which allows the ATM to behave differently depending on its current state. This include deposit, withdraw, transfer, and all the 20 only withdrawal rules required by assignment. First is pre-withdraw checks. Choose pre-withdraw checks. When we the in this rule we user select the withdraw so button B from in it, so check cache availability. If new 20s is less than 3, it shows no cache message. Dynamically calculate the withdrawal limit based on available 20 bills. Determine if ATM can only depends $20 bill using can only offer 20s method. If true, the user sees 20 only message before entering the withdraw amount. Then sec then a new withdraw state, which is pre-withdraw. In pre-withdraw shows the calculated withdrawal limit. Display the 20 only withdraw message before entering the amount. This specialized state that enforce 20 only. So check if the requested amount is multiple of 20. If not, transition to withdraw 20's warning. It gives the transition warning. Then handle the insufficient funds and request above the limit. Last is cash dispense and withdraw. This is standard withdrawal logic. So we use the greedy approach. The dispense $20 first, then $10, and finally one bills while deducting from ATM's cash inventory. So dispense 20s only. This is the method for 20 only withdrawals. Deduct the correct number of 20 bills and update the user account. Then withdrawing 20, so it process user enter amount and validate it and ensure no invalid input user can take. So if the amount passes all checks, the corresponding cash is dispensed and the user account is updated. So this is all logic behind the state design pattern, and further test case run by Ruchira.
I will now run the test cases. All the class files have been created. And now I'm ensuring that all the text files create. Okay, so as we can see, the GUI as per requirement. So in checking accounts, we have to just enter an amount. For now, I will cancel. And okay, we can also log in and log out. I will log in again. So in withdraw, we can see that our cash withdrawal limit is 500. And it also states that the ATM can only dispense the $20 bill. Then money market, it's withdraw few amount. Because we don't have insufficient fund, this transaction has been cancelled. Okay. Now, as per the requirement, let's check two of the files. I will go with test run 3 and I will also download the actual test run file 3. So we can see uh, that the test file for test case 3, so there is a $20 rule for the ATM. So the ATM is almost out of $1 bills on 310 3010 and what it proves that the restriction is triggered in here. So because $1 bills are low, the ATM currently forces the $20 only rule, that is message 1, the error, and it also checks when the user tries to withdraw $29. The ATM correctly shows an error because we can only request an amount that are multiples of $20. So there is a re-entry It proves that the user is sent back to re-enter a valid amount and for a valid amount for the same account. We can also see like the file output is same as what was required. I will also check with another test. Let's do it test 12. And in here, mm, in test file 12, we can see the limit works here. So as we have a limit of particular amount that is 100 for this. So the ATM has a medium amount cash that is 9 of $20, then 10 of $10 and 40 of $1. So it proves that the limit is set. It correctly calculated and announced the withdrawal limit as of $100. So it proves that ATM goes to the normal withdrawal screen. And because it's small enough bills, like the $20 on-re rule was needed, the transaction got cancelled. So we can see the output is similar for what was required and what is given. So that is our assignment. And Rupali, would you like to conclude
Yes,
this?
yes, yeah. So, in the conclusion, we implemented this new state and cash dispensing method, and we ensure that the ATM correctly handles all withdrawal scenarios, including insufficient funds, existing withdrawal limits, and 20 only withdrawals. This guarantees a robust error checking and precise cash dispensing logic in this assignment. Thank you.
Thank you.